Okay, so you can see the slides now, right? Uh, I guess so. Okay, so yeah, my name is Alex Manov. I'm working at JetBrains Research, and I'm here to present our work called IntelliTC, Automating Type Changes in IntelliJ IDEA. And so let me begin with the definition of type change, or what's actually a type change. And actually, the developers update the code, update the types of different variables and methods in their code very often. It could be done for many reasons, such as library migration, deprecation, security issues, and so on. They also adapt the code which refers to this element, like to this variable and or method, to the to the API of the new type. And what I mean is shown in the example. Like we can see here how type change from java.io.file to java.neo.file.path performed. So as we can see here, we have variable f, which type is being migrated from file to path. And also different usages of this variable should be also updated, like this exist call should now be files that exist and so on. So the motivation is kind of obvious at this point because such activity is tedious and overwhelms the developers. And current techniques are actually not enough because they break developers' workflow while working in the IDE, like working in the code editor, because they require some standalone applications and specific static code analysis tools like Google's Error-Prone or Silang's libtooling infrastructure. And what's more important, the state-of-the-art techniques for performing type changes require developers to handcraft rules for type changes. So we propose IntelliTC, a plugin for a configurable plugin for IntelliJ IDEA, which automates type change refactoring in Java. And the proposed pipeline is the following. So we have a set of type change patterns, as you can see here on the slide, which contains different transformation specifications on how to perform the particular type changes. And like this set was inferred initially. Yeah, initially this set contains 59 different type change patterns, which were inferred by our other tool called TC-Infer from GitHub repositories. And yeah, we have like another paper about this tool, about TC-Infer. It's our accompanying paper, which is also presented at XC 2022. So please welcome and visit this talk in a few days later, I guess. And yeah, any user of the plugin can surely extend this set of type change patterns and configure it. And so our plugin uses the set as an input, and also it uses different features of the IntelliJ platform, like a reference search and structural search and replace templates engine to provide the developer with different workflows. Like the inspection mode, for instance, which proactively highlights different places in the code editor where some type change could be performed. Also, the suggested refactoring mode, where the plugin operates where the plugin actually tracks the developer's needs to update some type and suggests the appropriate refactoring, and the classic mode, where the plugin works as a general code intention. So now let's switch to live demo, where I can show you how it actually works, and then get back to the slides to talk a little bit about the preliminary evaluation. So here you should see my IntelliJ IDEA opened, and here I like have some example project where I want to migrate some types in Java. So let's say I want to migrate this file to pass as we've seen on the slides. I can like I want to use the classic mode of the plugin. I choose this intention, data-driven type migration, and here I have a drop-down list, and I can choose what type when I want to change this file. Let's say I want to change it to pass, and also I can use the search scope for the type migration for the type change. For now, we support only three search scopes, like all the project scope, current file scope, and the local scope. Let's say it would be local scope, and I press migrate, and so it works. I'd say that 7 usages were migrated, and as we can see now, like migrated the constructor, for instance, here. Also, here was on the file, now it's file.toFile, and so on. The different usages of this variable were migrated here. As far as I like choosing the local scope, it's been migrated only within this scope of this function. Now let's switch to the inspection mode. And as you can see here, the plugin highlights the different misuses of Java 8 functional interfaces. For instance, here we have function integer. So let's see what the plugin wants to migrate. And let's say that it could be migrated to int unary operator. Let's do it. And yeah, we can see that there was a apply call. Now it's apply as int here. Also, this function string boolean could be migrated to predicate string, as we can see here. Yeah, it'll also change this usage of the predicate. Awesome. So now let's switch to the third workflow of the plugin. It's suggested refactoring. And let's say I see the string here, right? And I see that this is a regular expression. So I want to migrate it to pattern. I'm choosing this type, and I'm just like typing the new type pattern here. And here I see the new icon which appears on the gutter, which you can click and see the suggested type change. So the plugin suggests type change from string to the pattern. I also can press migrate, and here, yeah, it migrates to the pattern. Here was the s equals args. Now it s matcher args matches. So yeah, I guess it works something like this. Let's get back to the slides again. Yeah, let's talk a bit about the preliminary evaluation. As for the preliminary evaluation, we've asked we asked the opinion of 22 experienced software developers. We actually asked them to evaluate the potential usefulness of different plugin features, like this different workflows, like classic mode, suggested refactoring, and inspection mode. And yeah, they actually positively rated the general idea of the proposed of the plugin and the proposed pre-recorded demo videos of these workflows. And I should say that we've chosen this way of the evaluation since we already evaluated the precision and the recall of the plugin in our accompanying paper about TC-Infer, where we've evaluated the precision and the recall of the overall approach, like the proposed pipeline, including the TC-Infer, including like the refactoring miner, where the type changes were inferred. And here we just wanted to understand how the developers feel about the plugin, about the general idea, about like the different use cases and scenarios of like using this plugin in practice. So yeah, I guess that's it. Here you can see our emails and how to reach us. If you have any ideas or questions, please don't hesitate. And also there is a link where you can find the sources. The sources of the plugin is on GitHub. And here you can download it and find the download and install instructions. And yeah, I guess that's all. Thank you for listening. I'm ready to answer your questions if you have any.
Okay, thanks for the talk and the demonstration. Any questions from the audience? Okay, I have a small question. I see you are also from the JetBrains company. So this new feature will be integrated in the product as a permanent feature, or it is just a trial?
Actually, yeah, it's kind of good question. We haven't already implemented it in the production version of IntelliJ IDEA. Now it's just a plugin. Actually, like anyone could create the plugins for IntelliJ platform. It's very extensible, and like at this point, I'm not sure that it will be integrated like right now or very soon because we need like to support more patterns and to support some different edge cases. But we've already discussed it with the product managers of the IntelliJ IDEA, and they feel actually good about this plugin and this idea because like IntelliJ IDEA already supports some kind of type migration refactoring, but it's only for like several types, which supports Guava types from Google libraries, like so, and like it's not so extensive support. And yeah, we've discussed it, and I guess at some day it can come to production finally.
Okay, thank you. So, any other questions?
maybe if I just may unmute myself. So you've done this now.
So I think we can go on with our second talk. Then after all three talks is delivered, we can have some time to discuss among all the papers. Okay.
May I just ask?
Okay. Thanks, Oleg, again for your presentation. Thank you.
I guess we have one more question. Quick question. Is it
here?
Yeah.
If I may. My question would be, you've done this now for Java, which is very nice. Have you thought of doing this for other languages as well, or is this a language agnostic approach? I'm especially thinking what would be nice is if you write Python or TypeScript code where you basically annotate the code, you have a similar scenario, of course, where you might want to change your type signatures, although they might not influence the program running in the interpreter itself, but still it might be helpful. Is this kind of language agnostic that you can plug in basically every language with some front end, or how does this work?
Yeah, I got it. It's a good question. I guess now it only supports Java because it relies heavily on the PSI elements. The PSI is a concrete syntax tree abstraction in the IntelliJ platform in which this plugin operates. So we use these PSI elements of the Java language, and actually, as I can say that it could be kind of easily migrated to support Kotlin language. I'm sure you're aware of Kotlin, because the Kotlin, the abstract syntax tree of Kotlin is kind of similar to Java abstract syntax tree, and so I guess we can support Kotlin easily. But I'm not sure about the other languages. It's a good point, yeah. But now it's kind of a restriction of the platform, I guess, because PSI elements is for any other language, but they differ, so the AST differs, and I think it's kind of hard to support the language agnostic tool, but it's like a good direction of the future work, I guess. I'm not sure actually about Python, because Python is dynamically typed language, and here we are talking about statically typed languages where we can just find the usages of the element and see which type of the each usage is. So
my question here, well, my idea was here more like if you have type annotation available, which you can do in Python, and use that similar, like you would, or consider this like similar to a statically typed language with these type annotations. Otherwise, of course, if you do not have information about the types or dynamic
thank you, Alex. Again, I can, if we have more time after all the three talks is delivered, we can discuss among the speakers and among the audience.
Okay.
Thank you. So let's go ahead with our second speaker. He's Stevenson from University of Seoul, and he's going to talk about the automatic unit test generation. Okay, welcome.
Thank you for the introduction. Thank you for being here.
Stevenson, I have saw him before at the beginning of this session.
I'm here. Can you hear me? Can anybody hear me? Hi.
Yeah, we can hear you.
Okay. Do you also see my slides? I've just shared the screen.
Our second speaker? I'm afraid his network is temporarily down.
Oleg can hear me? Is anybody else?
Yeah. It's strange.
Yes, we can hear you. Oleg, did you stop sharing your screen? Or?
Yeah, stop.
Okay.
I can start sharing my screen, but I've stopped.
I stop and restart screen sharing again. Maybe this helps. So it's now shared. I don't know, we had this previously too, where we lost
Hello, Stephen. Can you hear me?
Hi, I'm here. Yeah, I hear you. Can you hear me? Can you hear me? I can hear you.
Yes.
Hello.
Yeah,
yes,
hi.
We can hear.
So I don't know. You cannot hear me, but everybody else can hear me. Looks like so. Do you also see my slides, or is this something that's lost now?
We do. automated unit test generation for Python.
Yeah.
Right?
So you see the slides here.
Well, sometimes it happens for some viewers. It may take some time to appear.
Okay.
So if somebody is
Hello.
seeing that, it means that the
Stephen,
slides
the
are
second
there.
speaker, our second speaker.
Yeah, I'm here.
I think I have saw him
Yeah, I'm here.
at the beginning of this session.
Yes,
I don't
Stefan
Oh,
is
it's
here.
strange. Oh, okay. I just want to ask, where is our third speaker? Is our third speaker, Guanbi Liu, is in this room? Maybe
Hello?
we can.
Can you hear me?
Yes.
The second speaker is in the room.
Yeah, I'm here.
Yes, I think I can, but is he's in the room?
Yeah, I'm
Yes,
here.
yes.
But what's the problem? He can't hear us, or we can't hear him.
I guess we all can hear him except you. Maybe you could rejoin. Maybe somebody could rejoin his friend.
So this worked before when we tested it before the session. I don't know.
Yeah.
So seems like everybody can hear me except the session chair. And I don't know
guess
whether you
so.
see my screen.
Yeah. We don't see a screen. Or, at least I can only hear you.
Okay, but you don't see a screen.
Yeah.
Okay, that's strange. Does it now work?
I think.
I don't know.
No. We see like there's some gray overlay where we can choose participant.
Yeah, I
and,
just
like
tried
the
it.
avatars of different.
I just tried it and
Oh,
selected
okay,
my
okay.
screen. I don't know. So this happened as soon as the recording was started.
Oh, now we can see the screen.
Yeah, it
Okay.
appears now. Yeah. I
Okay,
guess
so-
it's there.
I guess I just go ahead and give my presentation, and we will see what happens. So sorry for the inconvenience. I guess this is some technical issue that we were facing here that worked before. So my name is Stefan Lukaszek. I'm a PhD student at the University. Okay, so for some reason it kicked me out of the room. Let me quickly restart this. I cannot even unshare the screen. So what's going on there?
Hello, I cannot hear. I cannot hear anybody, and I cannot see the screen.
I can hear you, and it just kicked me out of the room. I just go out and rejoin. Give me a sec, please. So now I'm here. Can you hear me, Shunji?
Yes, we can hear you.
So now I cannot share my screen anymore for some reason. I don't know.
So there's like no button at the like a bottom left for sharing screen.
Yeah, but it says I cannot. It does not open anything. I cannot share. Failed to unshare, but it is not shared. So I don't know what's going on there. Okay, so but I don't know when you don't see any screen, that might not be very reasonable. Can we maybe have the third talk first, and I try to restart my browser?
I guess session chair also disappeared.
Okay.
Maybe we can try the third one and then we can go back to you.
Yeah, maybe if the third one could just take over, please.
Who's the third presenter? Do we have the third presenter?
They used to
Okay,
be there.
can you hear me?
Yeah.
Yeah, can you share your screen and then we see whether it works for you, then we can start with you and then we can go back to Stefan.
Okay, can you see the screen?
Yeah.
Okay. I will give a brief introduction to our proposed tool called TopHat, test data augmentation of point clouds by adversarial mutation. First, I will give an introduction to this paper. Point clouds has been widely used in a large number of application scenarios to handle with various deep learning tasks. Testing is the essential means to guarantee the robustness of DL models, which places high demands on test data. However, compared with the datasets of common types, such as images, point clouds are limited in number and less labeled. Therefore, it's crucial to design a reliable and effective point cloud data augmentation tool to generate high-quality data to test the robustness of target model. Further, let's talk about the methodology of this paper. We proposed a tool called TopHat based on adversarial mutation, which is the first attempt to guide the effective mutation with adversarial attacks. TopHat includes three main components: point clouds pre-processing component, point clouds adversarial mutation component, and spatial distribution restoration component. Specifically, point clouds pre-processing component contains two stages: point cloud resampling and metamorphic operators multiplication. Point cloud resampling aims to make the input data match the structure and data interval that the target DL model can handle. Metamorphic operator multiplication ensures that even the same resampled point cloud can be augmented to different data. Point cloud's adversarial mutation component performs adversarial mutation on point clouds to generate flood-prone data. TopHat introduced the adversarial attacks to guide the specific direction of data mutation. The balanced mutation operator is proposed and implemented to ensure that the data zero-centering and the normalization operation are unable to resist our mutation. The spatial distribution restoration component restores the spatial displacement and size scaling during the execution of pre-processing component, making the final augmented point clouds be highly spatially similar to the original data, where they can lead the model to make misclassifications. TopHat can reliably and effectively augment high-quality point clouds, which contributes to point cloud model testing. Finally, let's talk about the usage of TopHat. TopHat provides user-friendly interfaces. Users can easily perform test data augmentation through parameters configuration. TopHat provides a convenient way to configure the augmentation task by simply dragging the slider corresponding to the parameters, or directly entering the specific parameters value, and uploading or selecting the target augmentation dataset. Users can get the information and real-time status of all current tasks from the task list, and download the original point clouds and the augmented data. In addition, TopHat provides visualization of the original point clouds, the augmented point clouds, and their superimposed comparison. Users can directly select the completed tasks from the task list for visualization, or upload the point clouds locally TOPAD implements microservice architecture. TOPAD uses PointNet as the target model, which has been widely used in the variety of application scenarios and has achieved good results. TOPAD uses Knuckles as the service registry and discovery center. Celery is used to handle the sending of heartbeat packages to Knuckles and the async task processing of microservice. The server end is based on the Django REST framework, and the client end is based on the Vue framework with Element UI. Both the server and the client end are loaded balanced by Nginx. TOPAD applies MyCircle as the primary database for data persistence, as big tasks of Celery with Django need databases to manage custom schedule classes. Each augmentation microservice uses SQLite as the auxiliary database. TOPAD also uses Redis to cache data, store the system status, and act as the broker of Celery. Docker is used to packaging and deploying microservices with their dependencies in containers, and Docker Compose is used to define and run multi-container microservices at the same time. That's all. Thank you for your listening. Anybody questions?
Do you hear me? Hello.
Hello?
I have a question. Why balanced mutation is needed, and can you give the working details of the balanced mutation?
Okay. Expected augmented data should be ensured that it can accurately detect the target defects. However, GL models for point clouds often perform data zero centering and normalization before the data are fed into the models. These processes can resist part of the attacks, which modify the data value of the point cloud, making it unable to maintain the general mutated data. The mutation operator called balanced mutation we proposed can ensure that our attacks can be consistently effective. The working details of the balanced mutation are as follows. First, the backpropagated gradient matrix need to be filtered. Considering the sign function, the element values in the matrix only consist of -1, 0, and 1. Each element of the matrix corresponds to one dimension of a point in the point cloud. Therefore, it's necessary to check whether each dimension value of the point plus its product of the corresponding element value of the gradient matrix and the mutation amplitude exceeds the bound set during the data normalization. Of course, if it does, the corresponding element of the gradient matrix should be set to 0. This step makes the normalization operation unable to resist our mutation. Then, TOPAD matches the elements in the gradient matrix in pairs according to dimensions. For each dimension, TOPAD retrieves all the corresponding elements in the gradient matrix and finds the elements with a value of -1 and 1 in pairs among them. The values of these redundant non-zero elements which can't be paired are all set to 0. This step makes the mean of each dimension mutation as a whole is 0, making the zero meaning operation can't withstand our mutation. Okay, any questions more?
Could you show us the details of data zero centering, data normalization, and the rotation metographic operator?
So we first talk about data zero centering. Given the complexity of spatial structure of point clouds, this method ensures that the point cloud is located at the center of the space. In other words, the center of point cloud is located at 0, 0, 0 of the 3D coordinate system. Then we discuss the data normalization. The range of values corresponding to different point clouds is always distinct. So all point clouds need to be normalized into a specific data interval, enabling the DL model can classify them properly. The rotation metamorphic operator rotates the resampled point cloud around the spatial z-axis at random angles. arbitrary rotation is not allowed, since it may lead to changes in the labels. For example, the resampled point cloud of a chef's hat flips over is highly similar to that of a paper cup. Top hat selects the random angle theta for a range of 0 to 2 pi. The new coordinate value of a point xyz in the point clouds after rotation is x cosine theta minus 1 sine theta, x sine theta plus y cosine theta, z. That's all. Thank you. The third speaker, please.
So I hope this now works. Stefan, do you mind to stop sharing the screen, please? Right. Share mine. Can you hear me and can you see my screen?
Yeah, now it's
that's perfect. So sorry for the inconvenience before. I don't know what happened there. It worked when we tried it out for the session, but yeah, okay. My name is Stefan Lukaszek. Welcome to this presentation with a 15-minute delay on our automated unit test generation framework, Penguin, that we've proposed and that I want to present to you and show you today. So consider you're working on a project with some Python code, and you now have this code and your manager comes to you and says, well, provide me some test cases for that code because our customer wants that. We have some quality that we need to fulfill. So what can you do to come up with these test cases? Well, of course, you could sit down and bang them out of the rock manually, which is often considered a tedious work, time-consuming, and many developers think that's annoying and they don't like that to do. Or, well, you're aiming for something different, don't you? And that's why we came up with our framework Penguin, which is an automated unit test generation framework for Python that explicitly targets your problem that you now have. So consider, again, we're starting with some Python code, and actually we come back to that code later, so we don't look into that now. And you want to end up with some tests that Penguin generates, and we will also look at that in a couple of minutes. First of all, I want to show you how we come from your code to your tests, basically how Penguin is built. So Penguin is a modular framework with a couple of stages, and I'm going to talk about these stages for a brief while. First of all, Penguin loads your module and analyzes this module. So these are static analysis that are taking place here. Basically, it extracts which functions are there, which classes, which methods. And from that information, it builds a so-called test cluster, which basically gives you all the information about your subject for that you want to generate the tests. So, for example, the functions and methods, as I've said. Of course, there's also some environment usually that you have, or some context, as we called it. This context consists of all the other classes in your project or in the dependency tree, maybe also the built-in functions and modules and classes that are there in Python. All those get incorporated in the analysis and are present in the test cluster to allow Penguin to select from it and to generate your test cases. In order to do so in this test case generation, you can select from a couple of different algorithms, for example, the Dynamosa or whole suite approach, which are well-known and well-established techniques and algorithms for test case generation and well-known from other tools in the Java world, for example. So when Penguin generates tests, basically it generates a sequence of statements and executes these sequence of statements, which are combined as test cases, to learn what parts of the code are executed, for example, and to see what happens there and whether you can cover all these statements or all the branches in your subject under test. If you have covered those or reached some other goal, like a time limit or something else that you can select, you basically also want to have assertions on your test cases. So up to then you also have, you only have a list of statements basically that calls your subject. So this assertion generation currently is based on a mutation-based approach where the original code under test gets mutated, and we try to kill these mutants with our newly generated test cases. And all the relevant assertions that kill mutants will survive in the final test cases that we can now export, and you will come to the test cases that you want, and you have them available. Before I go into demo, I want to quickly say Penguin is an open source framework. It's available from GitHub, and you find all the information on its website, penguin.eu. But now let's dive straightly into how to generate test cases. So I have this code example that we have seen here. It's a basic queue implementation, a small class, which consists of a couple of methods here that we see. We have a constructor method. We have two methods to check whether the queue is empty or full. And you have two methods, one for enqueue and one for dequeuing numbers. In this case, we consider to have a queue of ints, but in general to consider any, to queue and dequeue any objects. So we have this module available, and we now want to run Penguin on it. And I've already prepared that here. I've installed Penguin to a virtual environment, and thus I can just run it from the command line. So it's a command line tool, and if I just call Penguin, and it gives me a lot of output, which is basically all the configuration settings that you have, where you can select, for example, the different algorithms that we have seen. You can select a timeout, basically a lot of possibilities that you can configure there to get the best out of the tool for your current scenario. So what I want to do now and what I want to show now is how to generate test cases for the module that we have seen. And in order to do that, I again start on typing Penguin, and I set a couple of parameters. The parameters, the first three that I'm going to set are the ones that you need to set. The first one is the project path, which is the path to the project where you have stored your project files. So this queue example that we have seen is in the current path. So I use just the dot as a shorthand for that. I also set an output path, and I also want to write the output to this directory here that we are in. I set the module name, and the module of name of this module was queue example, so I set this. The other two parameters I'm going to set is a seed to avoid random effects. So Penguin is based on a lot of randomness here to generate the test cases, and to have a reproducible execution, I just use a seed that I have selected previously. And I also set the verbose mode because otherwise Penguin won't show you too much output. And if I hit the run button, this runs for a couple of seconds, and you see it does something, and I'll go over this now for a couple of seconds. So Penguin starts, it tells me the seed again that I set here. It tells me that it used Dynamoser as a strategy and some of its parameters and options that we have set here. And then it starts to generate a population. So it starts with an initial population that's randomly sampled, so selection of test cases. And these test cases come up with a coverage, in this case, of almost 79%, which is pretty good, but it's not what we can achieve. In order to increase this coverage, Penguin starts now to this evolutionary algorithm starts to mutate, starts to do crossover, adds new test cases. And after 8 iterations of the Dynamoser algorithm, it yields the full coverage, meaning in this case, branch coverage. All branches of the module under test have been covered, and we can stop the test generation, so the input generation here. Afterwards, Penguin will generate the assertions, and for that, it uses the aforementioned mutation-based approach. We can see here from the output that it generates 31 mutants out of this module that we have seen here, and it will then run the test case, the generated test cases against all those 31 mutants, trying to kill all those mutants and build the best assertions that are necessary for that. And in the end, it writes out the test cases, and we can also have a quick look at this on the right side of the screen. This is how the output looks like. Basically, it sets up some values, some objects, in this case, the constructor. It also incorporates some assertions about the preconditions that should be met here when you instantiate this class, that you also can see again on the left side. And then it calls some method, in this case, for example, the empty method, and checks whether this value holds or not. And in this case, it assumes that it's false. And this is done for all the methods that are there. It queues and dequeues and the values there, and also generates a couple of more methods that I want to skip for time reasons. But let me quickly come back to my slides to summarize what we've seen to you. I've shown you Penguin, our unit test generation framework for Python. We have seen it running on a small example now. Penguin is available from GitHub as an open source software, and we would love to hear your feedback from your experiments that you have done with Penguin. And that's from my side. Thank you for watching this presentation, and I'm open for your questions.
Thank you very much for the talk. I guess I have a question. It's about the dynamic typing, like the dynamic nature of Python. I had a quick look at your paper where you say that you support different type inference tools, like for inferring like the type of the inputs. And I just wanted to ask you how actually you use them. How, like, could you please elaborate on this point? And because as far as I can understand, this type of inference tools like can be not enough, because maybe like what can you do if the type of inference say that the type of some input is like a union of like 20 different types? What can you do at this point? Like how can you generate the appropriate input for such type?
Yeah, thank you for this excellent question. That's actually something that should be mentioned maybe here in the analysis stage. So there are different things that can happen. So the easy or the smallest thing is that there are no type information at all, which is true for a lot of code that's out there. Then in recent Python versions, you can annotate the types directly in your code, which looks similar to you have it like in Java or in Kotlin. In this case, Penguin is able to extract this information in the analysis stage. We will collect everything that's there. Basically, when you have a union type, a union is just a set of different types that could be there. So in the generation phase, Penguin selects of one of these types in the union. In the case of the union, it randomly just selects one of those. So if you have a union of int and float, it might come up with an int value here, or it might come up with a float value. The problem that's open for research when it comes to union types, to especially target your question, is it does not differ. If it's successful with one type, it does not check for the other type. So if you have a successful test case that executes everything with an int, it should also generate one for a float, which is something that we currently working on and that we need to add in a future version of Penguin. And the third thing regarding your question is external type inference tools. And there have been a lot of work in recent years, especially with machine learning based models that can also be incorporated, and we're currently working on that to plugging in the output of these tools, basically also bring this to the analysis phase, and that it is incorporated in the test cluster. And then you have a similar problem. You have maybe the top 3 or top 5 suggestions from your type inference framework that are there, and then you need to select in the test case generation which one you want to use for the input generation. So I hope this answers your question.
Yeah, I guess so. Thank you.
Yeah, thanks, Stefan. We have a question in the chat as well. Maybe you want to respond to that?
So the question is, what were some of the unique challenges you encountered when generating tests in Python versus other languages? One of the unique challenges, but one of the challenges that we encountered is related to this dynamic typing of Python and the non-availability of type information for many projects that are out there. So a lot of code does not provide any type information, and then you can just guess what the type is. Of course, you can incorporate the information from executing the test then back and propagate this back. But in the first place, when you generate the inputs in the test generation phase, you don't know what to generate, and you can just pick any arbitrary type that you have in your test cluster and see what happens. So in statically typed languages such as Java, you have the types annotated in your code, of course, and you basically have in this stage, you just need to figure out how to generate your objects. Here in Python, you often don't know what type you expect, so you have to figure out what type and how to generate your objects, which is basically the problem, twice, or two different problems that are complicated and that are not easy to solve. But this is one of the maybe most prominent changes or challenges that you see here. And in our work that we have done so far, we have analyzed this and see that if you have type information available and you can use it, this leads to significantly higher coverage in the test generation than you if you don't have this information available.
Stefan, do we have any more questions?
So
I have a small question.
Yeah.
My network is down right now. So sorry for that. For example, for the deep learning system with such as PyTorch, the input might be, for example, for an array, they need a specific type. I just want to know your tool is capable of handling that type of the input.
I did not get the question. Could you please repeat it? There was some noise on the audio.
Okay, I just want to ask for the deep learning system, for example, the PyTorch, the input is an array in a specific type. For example, array is 3 multiply 4 multiply 5. They need to import this type of array to make it pass the compiler. I just want to know whether your tool is capable of handling such things.
If I got it correctly, it's basically about inputs and inputs if you have, like, for example, a file. So in this case, that's a difficult thing, and this is nothing that Penguin currently is able to generate. Inputs of this structured type, I'd say that's a whole problem in test case generation at all. There are approaches, for example, grammar-based fuzzing that target these things, where you basically come up with a context-free grammar that describes your file format, for example, and you can use that to generate valid inputs. But this is nothing that's currently implemented in Penguin, which is something that we would love to do as future work, of course.
Okay, thank you. I see there are 2 other questions in the chat channel.
Yeah.
Can you see it?
So one is, Penguin is strictly for regression testing. How difficult is it to update the tests upon bug fixes of existing code? That's a very good question. Actually, I'm currently doing some experiments on this, and I have not yet any results, but you could, of course, try to do that if you know from the bug. So if you have a bug in a fixed version, you can, of course, generate a regression test for the fixed version and run it against the buggy version and see whether the bug is exposed. But bug hunting in general, like you would expect, for example, from a fuzzing tool, where you see a crash, for example, as the outcome of this input that exposes the bug, is not currently implemented in Penguin, which of course is some interesting thing for the future. The other question, I hope that answers the first one. The other question is on mocking when generating tests. This is also open for future work. This is currently, unfortunately, I would love to have this, but it's currently not implemented in Penguin and open for future work. By the way, if you're interested in that, or you want to add something, feel free to talk to me or to submit me a pull request. We are happy to add some functionality, of course.
Okay, I think we still have time for a quick question. Are there any questions?
Yeah, maybe I have one more question. I'm not sure like if it's a correct question, but do you have any hyperparameters, I don't know, to regulate the atomicity of the tests? You know, that maybe your tool can just generate a one very big unit test, you know, that will cover in the model. And can you just split it? Do you have any parameters just to regulate the split in it to small parts to be like actually unit tests?
That's another very good question, and thank you for that. This gives me another to do, I guess. So currently it doesn't do that, but yeah, that's something that's a very good idea, and I'll take that, and we try to add something like that as soon as possible. I mean, this could basically be narrowed down to say, okay, here is a function, just select, create a test for that function, that you basically not only specify the input module, but also a function in that module, and it does not aim to cover all the rest of the module. That's a very good suggestion. Thank you for that.
Yeah, welcome. Awesome. Thanks.
Okay, let's thanks for Stephen again, and for the presentation and the demonstration, and also the answers for all the questions. I think we have run out of time for this session, and if you have any first questions, you may can leave text message in the chat or go for specific people for the one-to-one, face-to-face discussion. And I hope you can enjoy the other sessions. Okay, thank you.
Yeah, thank you again. I'll be around. If you have further questions, just ping me on some chat or wherever you meet me. Thank you.
Okay.
Thank you.
Thank you. Bye.
Thank you. Bye.